What if changing a single URL parameter could expose an administrator's password? In this video, we'll exploit a critical access control flaw to do exactly that. User ID controlled by request parameter with password disclosure. This lab has a user account page that contains the current user's existing password, pre-filled in a masked input. To solve the lab, retrieve the administrator's password, then use it to delete the user Carlos. Let's start by analyzing how the application handles user profiles. With Burp running in the background, navigate to the My Account page and log in using the provided credentials, Wiener, Peter. Now let's switch over to Burp's HTTP History tab and look at the Get My Account request. Looking closely at the response body, we can see that the application renders our sensitive account details, including our plain text password, directly into the HTML. This tells us two things. The application relies entirely on the ID query parameter to fetch data, and it leaks sensitive credentials in the response body. Send the request to Burp Repeater. In Repeater, change the ID parameter in the query path from Wiener to Administrator, and send the modified request. 200 OK response indicates that the backend blindly trusts the ID parameter without verifying our session cookie. Inspect the response body. Because there are no server-side access checks, the server returns the administrator's profile HTML, completely exposing their plaintext password. Copy the administrator's password from the response. Switch back to browser and log out Wiener. Now log back in as administrator. And delete the user Carlos from the admin panel. The lab is solved. The vulnerability we exploited is an insecure direct object reference, along with a design flaw, known as insecure sensitive data presentation. Technically, what we just performed is a horizontal to vertical privilege escalation. Looking at the industry standards, this vulnerability falls under OWASP Top 10, AO1 2025, Broken Access Control. It also heavily overlaps with AO4 2025, Cryptographic Failures. In the Common Weakness Enumeration Framework, we can map this to three specific flaws: CWE 639, Authorization Bypass through User-Controlled Key; CWE 213, Exposure of Sensitive Information due to Incompatible Policies; and CWE 312, Cleartext Storage of Sensitive Information.